Right, so let's look at some concepts pertaining to pH. So these are just three short questions regarding pH. And the first one is, it says vinegar has an hydronium ion concentration of so much molar, determine the pH. And it's a basic application of what pH is all about, because we know pH, this definition is all about pH is equal to minus the log of the concentration of hydronium, equal to minus log 1.55 multiplied by 10 to the minus 3. Then how many significant figures? 3, so it means 3 after the decimal point, so you round to 2.810. 3 significant figures after the decimal point. Remember, that's how the pH scale works. And you can see that's very acidic, right? And vinegar is acidic, so it's not a shock. B, household ammonia has a pH of 11.28, so that's basic, also shouldn't be a shock to you. Determine the concentration of H3O plus and OH minus. Now, we can also work the opposite way. If the pH is 11.28, that means that the concentration of H3O plus is equal to 10 to the power minus pH. Right, which is then 10 to the power minus 11.28, which is 5.2 times 10 to the power negative 12. Why two significant figures? Why 5.2? Because it's 11.28. So pH, once again, you look 2 after, so it gives us 2 decimals, so it's 2 significant figures. You count after the decimal place. And then we know there's a rule, or how we define pH and pOH. pH plus pOH must be 14. So we can determine the pOH to give us the OH concentration. That's going to be 14 minus the pH, 2.72. And we can write something similar, that the OH concentration is equal to 10 to the power minus pOH. And of course, that is 10 to the power minus 2.72. You're going to get a value of 1.9 times 10 to the power minus 3. Of course, these are molar values. Okay, so importantly, you need to remember this relationship between pH and pOH, and the relationship between these quantities. Okay, let's look at the last one. The solution of sulfuric acid has a concentration of 0.004 molar. Determine the pH of the solution. Now, the important thing that we need to remember here is that H2SO4 in water is going to produce not only 1 mole of hydronium, it's going to produce 2 mole of hydronium. Right, so it's going to react with 2 mole of water. And I think that's the part where usually the issue comes in, is that it's forgotten that 1 mole of H2SO4 implies 2 mole of H3O plus. So the concentration of H3O plus in this case is 0.0080 molar. Since it's a strong acid and it fully ionizes, we can take it just as how many ever protons it loses. So if it was a triprotic acid, it would have been 3 times the concentration of the acid. Right, so you just need to remind yourself of that. And then it is simple from there. Then it means the pH is, of course, just again minus the log of H3O plus. And you should get 2.10. Two significant figures, very strong acid, very low pH. Makes sense. Okay. So short revision, example video on pH. I hope it was useful, and I'll see you in the next one. Thank you for watching.